Welcome to a new episode of SDV Coffee Talk with amazing guests and amazing topics today. We will talk about shift left strategy in SDV and what it is and what it is not. Just a small disclaimer from my side. Everything what I say here is my own opinion and has nothing to do with my employer. So let's start. I would say have a short intro. Vinicius, do you want to start?
Yes, my pleasure. Thanks for the invite, Fatih. It's a pleasure to be here. So Vinicius Zain here speaking. I work right now as chief architect for SDV and Meter platform at KPAT. I have around 8 years of experience in the automotive AD domain and ADAS domain, and recently then Meter. My background is on consumer electronics. Also worked with some telecommunications and health tech, medical devices, and energy as well. Always on embedded systems, different positions. Yeah, that's so much about myself. I'm Brazilian, married, 2 kids.
Cool. Florian?
Hey, yeah, so I'm a regular here, but for those who might be new, so I'm in the automotive industry for about 20 years. Probably the most interesting 6 years of those 20 was when I was responsible for vehicle level software validation at Tesla. And we basically created the SDV in 2012. We didn't name it like that. Also worked at Conti and at NIO, and I'm a consultant for iProcess Consulting now. And I represent both myself and the company. Handing over to Sergey.
Yeah, thank you guys. So I'm Sergey. I'm here also not the first time. But for those who doesn't know me, I worked in a couple of industries before. I worked in telecom for more than 10 years, then in automotive for more than 10 years. And I've been building software-defined products for a long time. Even before in automotive, we started to call it software-defined vehicles. So I was always trying to make it software-defined. So that's my background, working for a few interesting initiatives. One of them is Arrival in the UK for a long time. Now with Soda, I'm the founder and CEO of the company. So we are making all these great concepts we're discussing here a reality, a real thing, in practical implementation and building the future of automotive with SDV, AI, and digital twin today. So similar to Florian, whatever I'm telling here, you can consider both my personal opinion and the official position of the company.
Okay, thanks. Probably we can start straight with the topic. I mean, shift left. What does it mean actually? I mean, we can probably start with a short definition of what shift left means actually. I mean, Vinicius,
you want to take it on?
No. I think shift. We all here agree that shift left is like shifting everything towards the integration team, right? Let them do the job, so the integration team can do the job, right? So we push everything to them. No, right? So
I don't know. Some people understand like that, and they put more people. Yeah.
And that's where I believe things start. So the mentality of coming. So we had like a traditional way of developing with AutoSAR, where AutoSAR Classic mainly, where it was integration oriented. I'm not saying that is good or not. I'm just saying that in that matter, we use it to push things to a level that many things got integrated in a later stage. And that later stage is where you can start testing things for real. And if I would say where this rooted, that is part of it is regarding this, what I just mentioned. It's also about the ecosystem for automotive, where software was just a part number, right? So it's just a piece of it. So you have a hardware having a software inside, and the software was seen just as a part number. You just put it there, like you'd be putting an IC or a SoC, whatever you put there, you put the software and that's it. And that was usually delegated to tier ones and to other parts of the ecosystem. And was like with secondary information, it was not the first row of the vehicle, or was not so important as other parts of the vehicle. And when we shift left, we see then the software like in the center, And we start developing and adding good practices that are used in other sector industries. So in a very early stage, we are talking about different things that we are going to probably cover here. So that is for me the shift left. So it's completely the contrary what I said at the beginning. It's not shifting things to the integration team and letting team test very late. No, it's bringing the integration leaders, the UA leaders in the early stage, helping to define the architecture. And when you have a clear structure, clear architecture, you can validate that architecture, validate the assumptions, and move ahead, integrating and testing continuously.
I think originally the term, because you look at the timeline, right, it goes from left to the right. And as Vinicius says, you have your integration and validation at the very far right. And what you do with the shift left is you pull those guys in earlier into the process. And that is probably, that's one explanation probably. You can also see it for the V-example, for example, where you take the right side and you move it further over to the left, closer to the development. Either one works as an explanation for the terminology.
Yeah.
Okay.
Completely. I would add just add that shifting left has multiple dimensions here. One is time. So basically, you're trying to do the things earlier in time, but at the same time, you not just do that earlier, but you do that for improved quality and less issues at the later stage. At the same time, you also do that in multi dimensions of what you do with your simulation, what you do with the actual hardware tests, what you do with integrated testing as well. So you try to make the things in parallel rather than just waiting until a certain phase is accomplished. And by doing all of that, basically what you achieve is much better collaboration, because you make the alignment of different teams early in the process, which is critically important because you don't waste your time and resources on making something. First, you align on what you're trying to achieve, right? So that is a very key factor to start with, and then you run in parallel, and whatever impact is happening, then you can synchronize. So I think this is really fundamental for making shifting left really working, not just being a theoretical topic. We've got.
You have to show the second comment as well.
I mean, there is a disagreement from the audience that shift left means not only software centric.
But we are very software centric here.
No, I can add on this, and I agree completely with Alex and the comment. It's not only about software, perfect, but the problem is hardware normally is coming late. The final hardware is coming late. Now we can do many of the early, and that's the part where I need to touch base on what the aerospace process has, and we don't have in the automotive process, which is called so there is a big difference between verification and validation. So you validate the requirements through different means. One is design review, and you validate that requirement. And this is a practice that we do for the safety requirements in automotive, but we don't do for generic requirements. That's not like a common practice in automotive. Then what I wanted to say is that when you define your architecture and you're defining building blocks, and now I'm talking about building blocks that are harder parts. Let's say we are going to have our RT core talking to a performance core through a switch. Not talking that the safety island is part. No, I'm saying there is a separated ECU talking to the HPC, the performance core and the HPC through the switch. Now, how can I test that in an early stage? So probably I would take a Marvel board, evaluation board. I can take evaluation board from my RT core supplier, and I can take the HPC also as evaluation board, and I can connect those three things, and I can validate that the communication paradigm that I'm going to use, the way I'm going to communicate, I can validate that this is working. This is also shifting left. So you're going to validate that in an early stage. So you validate that your building blocks, they can be integrated earlier. So that is what we call early integration in our context, in the context I'm working. So we call it early integration, and that involves hardware. Another thing is what I advocate for is that you are going to have a software environment with some simulation environment. It could be just a software, just a build for the host, or could be emulator, whatever. You're going to have that. But as soon as possible, as soon as you have the hardware, build for that hardware, flash it, and check at least with minimal sanity tests that it's working. And that is part of the shift left as well. Thanks for the point, Alex.
But
I want to
question,
add
one comment from that. I mean, is this hardware is I mean, having hardware and software together, isn't this a problem actually? I mean, that for the shift left strategy, because hardware is always, you know, slow. Development is quite slow and it needs time and so on. And for shift left, it will not work with hardware. I mean, I think I'm not sure if this works well if you consider both.
I wanted to talk exactly about that real quick. So there are actually 3 different angles on attack there to really help the hardware to go further left. As Vinicius says, simulation is one of them, and we see virtual ECUs actually taking the stage more and more now. And I see Sergey might want to talk about that briefly. The other thing is to have faster hardware prototyping methods. At Tesla, for example, we just at one point we built our own hardware prototyping line, so to have turnover times that are measured in hours and not in days for new prototypes. And then the third is to add more capability to hardware to make it more flexible and configure it. It's basically like a simulation in the hardware. So processor in a loop comes to mind, where you have simulated peripherals around the hardware with a certain processor type and so on. Yeah, Sergey, your stage.
Yeah, look, I'll make it quick. So basically, of course, another dimension is actually the hardware and software and all other systems, because you also have electrical architecture as a part of the same equation, which you cannot remove. And whatever you do, you make as a component, then you combine into the system, then system of systems. Finally, you create a vehicle. So you cannot finish without hardware, but you definitely can start even prior to the moment you have it. So I will keep it very simple this way. But then I think one of the fundamental enablers of shifting left is just making these things in parallel, so you are not blocked when you don't have a hardware yet, but you still can start. So I think this is a very key element of it.
But in this context, what does it mean? How far we can go to left? You know, I mean, I hear this very often: shift left, shift left, shift left. This is such a buzzword, but no one tells actually how far you can go or how far you should go actually to the left side. I mean, should we start by the requirement? Should we go to the architecture? Where? The code? Or where is this shifting left thing actually? I mean,
I think it strongly depends on where you are in your maturity of your product and also what complexity you have. Ideally, if you have a mature platform, going back to Moritz's terms, right? You have an upgradable engineering platform, however you call that, innovation platform. There you can actually go very far left, right? So you can basically take your new approaches directly into the final product and test it on the target. If you have something that is very early stage or very immature, it's getting more tricky. But there are technologies evolving now that help you even there to get further to the left.
I think in order to determine where exactly to the left you want to go, you always need to consider the entire process, not just a segment of it or just one phase of it. And then when you combine your simulation, your even initial like high-level sketching and prototyping and putting high-level requirements, then to any sort of high-level architecture, going deeper to the systems design. So whatever you do, you connect the things, and you see how making the things early in the process help you reducing amount of problems later and slashing the time and cost of your process. When you control it together, then you find this sweet spot for yourself. Otherwise, you are sort of guessing, especially if you are trying just to optimize left side of the V model and trying to shift left. Yeah, that's definitely not helpful as such.
But how do you deal actually? I mean, usually in automotive, what I have seen, I had a couple of discussions also with different from different car makers, friends from different car makers. And the problem is usually in automotive, you have not requirements not in a good shape. I mean, they come usually, the requirements already are not in a good shape. And then you try to implement this, you want to shift left. I mean, but if the quality is so low of the requirements, how do you want to do that? I mean, I think everything is
think
the basis of this is the requirement actually.
Fatih, I think one big problem is, and I think it's also what Alfred brings up here. I don't know if you can bring that on the screen real quick. That in traditional automotive OEM thinking, you have those compartments, right? And requirements is one compartment, and then you have integration is one compartment way further to the right, and you have development in between, and then you have software design document, hardware design, and so on and so on and so on, and they're all set up separately. And shifting left also means actually to bring those closer together and at the early stage. I brought this example up earlier or in other episodes when at Tesla, we, at the very first stage, design of requirements or definition of requirements, we pulled in the validation team. So this gives you several advantages. First of all, you get valuable feedback right away from the experts of the validation, but you also get additional eyes on that and additional input. And the validation team gets actually a very good heads up what's coming down to them later. So that's also part of the whole concept.
But also interestingly, guys, I wanted to bring this topic a little bit late in this conversation, but I think it's the right time. Interestingly, that in addition to shift left, there is now increasingly popular shift right concept as well, where with whatever you do, you try to reach farther your actual target product with a real user and real feedback coming from that user to your development life cycle. So by combining both of them, you essentially try to get more data in the loop, to get data in a parallel kind of threads, but linked with each other. So I think what we are trying to discuss here is, of course, is not only shift left, but more integral work by totally different roles in one process, focused on one target, which is create a product which end users, customers would love, and which would mean all the regulatory and any other requirements as well.
But yeah, I mean, the biggest problem I think in automotive is that we have a very isolated tooling. If we consider, for example, an A-Spice, SW1 to 6 or so, all tooling for each level is somehow very separate. I mean, you have requirements in a completely different tool, then you have architecture in a different tool, the implementation is completely in a different place, and verification, validation, everything is disconnected more or less.
But I think don't forget that this is the traditional tool chain you're looking at right now in front of your inner eye. But there are actually folks working on better ways to do that and integrate that better. If you look at your traditional tool set, yes, you're right. And that's also what the traditional OEMs have right now. That's why they have a hard time to actually follow through with this.
I think that there are a few points I wanted to add. So based on the last minutes of discussion, so I would start with the latest point from Sergey. I think that goes exactly in the direction what Florian mentioned in the previous episode, that with SDV, the notion of SOP changes, and then if that changes, all the things that you build for shift left, for continuous integration, for in all senses, in all matter, that needs to continue to exist and go further during the SOP. So you need to maintain that and keep testing, enabling, so shortening the lead time and making that release available for the for the field, right? So to the new cars, for the cars that are already sold. Another point is related to where should we go to the lab. So I think there is no I like very much what you said about requirements and involving the quality team or the validation team in the early stage, because more eyes looking at the requirement is going to tell that, oh, you're writing something that doesn't make sense, even though it's well written, because it's not about having like a formula to write the requirements. Is that meaningful? That's what we do with validation in aerospace. So we check that. So that's like the process is so structured that it happens at early stage. And then once you are talking about building blocks in that in an architecture, you're going to have a design review, and out of that design review, you are going to have a list of things that you need to do to make sure that your architecture, the architecture you define it, is going to stitch together. That you're going to be able to keep that all together. And that could be the thing that I mentioned earlier, to put some evaluation board together to talk to each other. Could be some simulation that you do, anything like that. And that can be in a very early stage. You don't need to wait. There is an aspect though that we need. I was trying to separate in three parts, three kind of projects. One project is one situation is we are on the greenfield. We are starting something. So please, if you're at that, this is the best moment to start it right. So testing CI from the day zero, and CD, so continuous deployment or delivery, continuous delivery. I mean, for us in automotive, is not the delivery that we do with web and cloud. It is about having in the main all the artifacts available that you need to do a release, and enable that as a pull process. So you don't push the release, you pull it. You can just take it. So having that from day zero or day one in the project, that is essential. So if you are in the greenfield, do it right from the beginning. Second option is you have a project that is under development towards SOP. So there we need to assess it, immediately look at and check if you're doing that right, because it's still time to correct things. And then in the third case, you already SOP is gone through. You need to add new features. You need to patch something that happened. In that case, that should be case by case analyzed, and you need to do that to maximize your return of investment. So those are the thoughts I wanted to share based on the questions and the comments.
I mean, Michael says that it looks like more for a startup approach, not for a classical OEM. But
well, definitely easier. I mean, if you have established tool chains, they're really hard to get changed. But again, change is happening, and you have to embrace the change. And we see that at all size of OEMs, from really small, and I work with OEMs which are literally just a handful of people, all the way up to 750,000 people OEMs. They are looking into that right now because they are realizing that they have to adjust something. There is no golden bullet, one size fits all solution, of course. And the larger your organization is, the more complicated it's getting. But if you're overcomplicating things, then you're actually going in the wrong direction. I just wanted to follow up on one thing Sergey said earlier. The feature is out, and then you're shifting right by looking into what's going on with your product. I observe this a lot right now, that everybody is like gathering up and getting ready for releases, continuous integration. And then here's a release. Whoever wants it, do something with it. I have no plan who wants it, right? And there's a whole third of the thing is missing. So there's development, validation, and then there is release and rollout management. And the third part is something I'm working a lot right now with my customers over the last year or so. It's really a black hole for a lot of people to continue to plan rollouts, but also to consume, and that's what Sergey said, to monitor and consume data back and learn out of what your product is doing and your customers are doing.
Yeah.
One thing to add. Yeah. Go ahead.
Yeah. Go ahead. Yeah. So one thing to add, just to do your original question in terms of different tools. So we need to just also think about quantities sometimes. So even for a smaller organization today, normal process would require at least 15 different tools combined together. For bigger organizations, and we had interesting analytics coming from major customers. They bigger OEMs, they're saying that it can be easily hundreds of tools working together. Now, just think about whatever integration you're making, it can be done perfect technically, but amount of this integration, try to think what is this hundred of tiny extra modules which are making this things working together. And one example which I like to give in this case is actually Uber. Remember how we used to get taxi before? You actually need to know the number, then you call the number, you explain where you want you to be collected, and then you find a car, you get inside, and then they bring you to your destination. Sometimes you have to show the way. And then finally, they tell you that they do not accept cards and you have to find some cash somewhere. So it's a logical sequence of things. And if you think about it, it's not a problem. Like, yeah, I need to know the number, I call it. So like it's efficient process. It's logical. The principle is right. But now think of the ultimate level of automation which Uber brought to us, and amount of saving in terms of time and in terms of the efficiency which it brings together. So anything which is working as one, the main model, where you don't have to have complex integrations to make the things working, where you have to apply native ways to automate the data transformations and transitions from one step to another, when you have traceability and coverage automatically enabled by the tool chain itself, linked to your CI/CD pipeline, etc. So making your entire process right from the beginning, it brings totally new level of efficiency into the process. So even if the principle is right, decreasing complexity is definitely the right vector to look at.
And there was just a
I mean,
great
this
comment from Michael about
Yeah,
that. He says AI should help a lot with that. He was referring to the data consumption, but actually everything Sergey just listed up, there's a lot of new tools out there. So what my main message is here, don't just look at the tools that were available 5 years ago when you sourced them. There's a lot of stuff is changing, and there's tons of new opportunities and options out there right now.
I mean, this comment here, safety in cybersec, I think this is very important in context of especially SDVs. I mean, because in SDV you have a fully connected car 24/7, cybersecurity is a big issue and so on. But and safety is also a pain point, I think, because the safety issues, if you have, for example, software ASLD software or so, the regulation and also testing is very heavy. How can you shift left this? I mean, this is not so easy, I think.
Nothing is easy, but everything is achievable.
Any comments on that? I mean, safety, I think is.
So I think Fatih has a lag.
Okay.
Yeah. So what I would add in this, so the same thing Florian mentioned about putting the quality team together, the validation team together with the engineers. You need to start with safety very early as well, cybersecurity very early as well, and that will make a big difference. So I have one story. Working with a customer, doesn't matter from where, so some software being developed, and then there was a safety architect there, and then he was requested or demanded to design the safety architecture. Can you please design the safety architecture? That's not how it works, right? So first you should have an architecture that is safety compliant, let's say, right? So there is a software architecture, and this software architecture needs to have safety elements inside, or things that ensure safety, and you're not building in safety on top. So that's a wrong thought that we have, and you're going for fail if you keep this mindset. So it's a lot of things. A lot of things are kind of mindset changing, in my opinion.
Yeah, and 100% again. Back to the same comment about the different tools. So rather than putting separate tools for all of that, like all separate tools, everyone is happy with their own tool. What if it's a shared collaboration around one object? Because in the end, we're creating one product, right? Which is the vehicle, which has architecture, which has requirements. So everything needs to come together, and different teams needs to collaborate in one environment, whatever that is. It's one tool ideally, but whatever it is, it's still at least one room where they meet and discuss the things. And then next level is when it's the tool which can include aspects of safety and security and functionality all together, so everyone can bring their concerns and discuss openly in one shared workplace.
Yeah, I fully agree on that. I have two thoughts I wanted to bring back here. One, Eric's point about cybersecurity, that also needs to shift, as Sergey called it, right, because cybersecurity is something I cannot get right from the beginning because it's changing every day, right? So I have to monitor and I have to continue to actually explore new threats and so on. It's not possible to do everything on the first day, but obviously I have to do a maximum as I can on the first day. And then there was another one. Nina just had a great topic, very different topic, but I want to pick it up since I have the mic right now. Continuous certification. Very fascinating topic. Interesting. I talk with some of the regulatory side, and they are not opposed to it. They just, you know, they say, hey, if everybody is doing a software update every other week, we cannot certify that. It's just not possible. So we have to think about some options how we do that. And I don't know, Vinicius, if you have more detail in that, but in aerospace, there is self-certification and continuous certification programs available, right? So we have to think about that in automotive. How can I actually continue to be compliant without having to go to TÜV or UL all the time? Sorry, Eric, we're not coming every time.
Yeah.
The user experience and the same conversation, make it continuous, measuring the satisfaction, checking what the actual user need, not what some big boss in the organization thought that they need. So that is another aspect, and similar principles. I think the key word from this conversation is continuous engineering, continuous safety, continuous security, continuous user experience. Everything must be continuous.
But there are too many regulations. I don't know in different countries, but especially in Germany, for automotive, there are so many regulations. I don't know how this can be made continuously. You know, I mean,
but this is where, Fatih, where AI will help you a lot now, right? So you don't have to read all the ISO standards anymore. You just have to have the right tool and go with your compliance analysis through Don't send it to OpenAI. Have your own system for that. But feed it with those standards, and actually you get compliance analysis much faster. And then the output of that is what you put into your human team. Not waste their time with reading text.
100% to what Florian is saying, is because AI can do the summary for you. It can really help you to make it brief for you to understand the key difference, and then at the same time it can help you to guarantee that the level of actual checks on the lower level is sufficient to make sure that it's fully compliant, so you can see the traceability and coverage. So that really is achievable even today, and going forward is going to improve.
Yeah, I have just we don't get questions a lot. We only get
comments. Right?
That's all right. Keep them coming.
No, but I have one. I have one thing. So to maybe a question or kind of to debate. I'm also saying AI is going to be used extensively. There is one thing that I learned coming from aerospace. That was one single project, but I learned it so much setting up that process from scratch, coming from consumer electronics with my team coming from consumer electronics, and so they leave the process. So the engineers they are trained in the process. They understand the process, and of course, traceability. Collection of artifacts, linking, all of this took a lot of time before AI. So what I want to bring here is that we should not, in my opinion, I'm not advocating that AI is going to take the burden of understanding the process. Our engineers and the team there needs to understand the process in the beginning of each step of the process, but the mechanical part of the process and ensuring the quality of the process, all of this can be done through AI. That I agree completely. But I still, the way we see the process, and I often do this comparison, the way I saw the process from that project in aerospace, and the way I see the process here in automotive, or how I see the people see the process, is that in aerospace, we had a clear understanding about the process and the benefits of the process. So we try to leave that from the beginning. So I'm going to get those benefits. That's the reason I'm following the process. Here in automotive, I see the process coming as a late thing, as paperwork, and like just as cost, and not like to build a better product. And that's where AI is not going to help us. That's my point.
I mean, but homologation is a big topic in automotive at all. I mean, but how can this be probably integrated in CI system? In a CI, that you have a continuous homologation. I have no idea actually how this can be done.
It's fantastic. It can be integrated just perfectly fine, because you actually don't have to do it every time. You just implement it once, and as the name suggests, it continuously. So let's form a new term here: continuous homologation. Then. And then,
but how? But the homologation process is quite manual.
Well, the thing is that homologation is basically a set of requirements you have to fulfill, right? And what you do, and this is how we did it at Tesla, for example, as well. So you feed that set of requirements as part of your test cases into your continuous testing machine, and you're homologating your product every time you're running a regression test.
Yes.
Perfect.
And also, you need to have the impact analysis for all parts of your system and your process, so that whatever is changing, for example, new compliance, new regulations is appearing, you understand how it impacts your implementation. Or within your implementation, if you make any changes, you need to see if it is actually impacting any of the original requirements related to homologation or any certification tests you are going to pass. So when you control this, when you understand this impact every single iteration, this is how you can really stitch these things together and make it working as a holistic continuous process. Again, just by linking all the parts into one object, because what we engineer is not a hardware or software architecture. It starts early as a set of requirements, and it ends late as a product which actually generates some data in the field.
Mm-hmm. Yeah, and I mentioned that earlier. Just like go out and look out. The tools have changed significantly in 5 years. So you don't click on two requirements to link them together in Doors or Polarion. There's so much more to it, and there's so many more options out there. So every time somebody comes up and say, "Oh, this is not working because of the tools don't support it," it's like, when was the last time you checked the tools? Because if your tool is copyrighted in 2012. Then that's the reason for it.
Yeah, possibly you can know the answer since then. Yes,
but see, that is also so I built up that in 2015, 16 the process, and even though we had Doors, we did a lot of things that are kind of the shift left that we are talking about here for automotive. Even though tools, yes, they are a problem, but and they are much better now. They can be the solution. They were a problem. Now they can be a solution. Yeah, that is that's true. And but Fatih, do you know Ferrocin from the Rust compiler from Ferro System? They are also in Berlin. Ferrocin is being they are going through a continuous homologation for the compiler, for the Rust compiler. So that's a very good example. It's going to come up as a tool in your process because it's the compiler, but it needs to have a very high stake in terms of a process, because of it's going to affect the result that goes in the vehicle so directly. Therefore, they are following that process continuously. So that's a process as a reference. This is happening, and the same thing. What I was discussing, or the team at Siemens I was working for, was discussing to have in the energy context as well. So to have like photovoltaic inverters continuously certified.
I want to jump back to a statement Alfred put up there a couple of questions or comments ago about old processes clinch to old tools, and old tools cling to old processes. So basically, it's like a catch-22. You stick with your old process because it supports the tools you have, and you stick with the tools because they satisfy the process requirement. And I personally believe a good process is actually continuously changing and is adapting to your needs. So if you have something that is called an old process, that is already the beginning of the problem. And most of those quote unquote old processes have been defined by people not originally involved in the product development, but for sure not in the current product development. And I mentioned that a lot in these episodes before. At Tesla, for example, very process driven, but we were owning the process as the user, and we were modifying the process every time we ran into an issue that it didn't work. And if we changed the tool, we changed the process, whatever, on a continuous base. So almost like every week you have a new process. Obviously not that crazy large changes, but every time you run into an issue with your process, don't stick to it.
Yeah.
I mean, there is a question actually, not a statement, about
cost of change. Look, guys, I mean, everything costs something, right? So I have an interesting perspective to put it. Like, but is there an option not to change?
This certification, this integration and certification, but the way.
All right. So I think Fadi has a little connection issue. I think the problem, or not the problem here, the answer here is short-term cost versus long-term cost. If you don't invest in the change right now, you will have a large loss of income. And I don't want to bring up Nokia as an example again, but they didn't invest into touch screens and stuff like this. So if you don't invest into this change now, you almost certain that you will lose a lot of income in the mid-term to long term.
Simply speaking, it can be too late as well. I mean, it's in today's world with everything which we see and new drivers and new changes are just appearing every day. You simply have to move fast, and if you're not moving fast enough, it's a risk as such. So without changing your entire system, set of processes, mindset, it's very difficult to bring radical change, and that is a risk. I mean, that should be one of the major risks for any OEM, and not only OEM, any automotive organization of today.
Yeah, most of you know I just spent a week in China, and in China, the go-to-market timeline is now down to 14 months for a new model. So that obviously doesn't work if you start everything from scratch in a traditional waterfall style.
Oh, wow. Okay.
Yeah, of course, that's continuity, right? That is the continuity. Now, I wrote about that recently because I saw that happening so many times. So you start, you develop, and that is also regarding the historical way of working from the OEM. So you start, you develop, you have a good platform. After you went through all the hurdles with the tier one, so now you have a good product. You can go into SOP after 2 years delay, or how long it was. But then you are so tired of that tier one, and your purchasing team is looking for cost saving and so on. Then you move to another tier one, and then you start from scratch.
Yeah. So Vinicius, what you're saying is that like folks like controlling and purchasing and so should maybe also be integrated in the whole shift left process?
Their mindset needs to be changed, in my opinion. And coming to the question from Alan earlier, I did this exercise, but if you start doing try to calculate the cost of quality for every car. You can include a recall, you can include the validation, all this part. You're going to see how much money is going to be wasted. And this is so we are not going to change OEM mindset, just bring out let's shift left. No, that needs to be shown as a cost saving measure. And that is how we can, so if it's just a simple exercise, you just check how many vehicles this OEM is producing, how much cost one recall is costing, how many recalls we have for software reasons. You're going to land up, and here I'm stressing the software part. If we put the hardware, of course, the quality cost is going to be everything right then.
Yeah. So
the numbers go to billions, US dollars.
you're bringing a very
Easily.
good point here. So it's not just about improving the quality, but it's also about optimizing the system where quality plus cost comes together, and you monitor that and make it optimal for your use case, because it really depends on your volume, on your product. For some product, you have one requirement for quality and another requirement for cost, and vice versa. So it needs to be optimized for project, but you need to be in control over it.
Yeah, it's also that the business case cannot be broken down just to one vehicle anymore, from like start of production to end of production, etc. Like they did it in a classical fashion. You could put a number on it, right? And you say, we have to sell this car for this because we need to put this amount of people in there and this amount of effort and so on. But with the new, with the idea of SDVs, platform thinking, etc., whatever word you want to use for it, you have to change the entire mindset of the company, and that includes the purchasing people as well, right? And you cannot just like say like everything the car will cost has to be part of the sales price of the car, because now you also have the continuous revenue coming out later and so on.
Yes.
So they have to start to understand this as well.
Well, but it's new business models really, which help to like for procurement people to understand that there is a different animal which they need to somehow start working with. So it's just wider topic, but by providing this new business models is critical to reboot the system and to change the not only mindset but the entire view of what we are trying to achieve, the goal, changing the goal really as well.
Florian, you told that you were in China recently, but what is different? What they do differently? I mean, because actually they have no really experience with building cars, you know. But what do they do differently?
Well, I mean, there's a couple of different aspects to building cars. So there's one thing is to change the shape of metal and weld it together in order to have a vehicle, and for that they basically just brought in the knowledge from the outside. I mean, it's basically if you walk through those companies, there's like a large amount of people speaking German there. So they brought in engineers to do that part. But what they do is to do the SDV or whatever you want to call it part. They bring it in from what they learned from their whole smartphone industry and so on. So they bring similar to what we did at Tesla, by the way, and they bring those people on. So what you see is basically, and there's a variety of reasons why, but if you go through the streets over there, it's like very different than you walk through the streets over here in the United States. They don't have anything like old cars, and I know there's different reasons why they don't have old cars. But even then, their current vehicles, they look like they're 10 years ahead of what we see driving around here. And I meant to bring that up. Do you know what the biggest revolution in automotive was in the United States in the last 5 years? The split tailgate for pickup trucks. They put $4 million in a Super Bowl commercial for that, because they cut the tailgate into half so you can open it like this and like that. So what I'm saying is with that, the appetite and so on of the customers is very different over there. They want the newest stuff and they get the newest stuff. If you want to bring the newest stuff, SDV style, out here in the United States, the answer you will get, no, I need a V8 truck and I need that split tailgate because I was told so. But it's very different for the automotive companies here actually to sell innovation, because the people are not really interested in it. And I see similar things when you look through LinkedIn and so on, the comments. There's a lot of people also in Germany or in Europe not very interested in the latest and greatest. In China, that's different. Their appetite is different.
Okay. Oh, this is really interesting. This is, so to say, the mindset is different there. I mean, how they look on technology and innovation.
The reason can be debated. The mindset is different by order from above, right? But it is still it's still the case.
Okay. I see.
So now I have tons of comments over there. So Robert asked, what's the best practice changing the mindset of an entire company? If you want to put that in there, maybe. Yeah. So we've seen different, and Robert, I know that you know probably more than we all together about this, but we've seen different approaches on that. Start a separate company within the company, start a separate company outside of the company, start by acquiring a company that has already a different mindset. We've seen a lot of those options failing in a lot of different ways. We've seen some sort of success in some areas. But the fish stinks from the head. That's the first problem, right? So as long as your leadership team is not embracing change and it's still going old school, then you can actually you will find a hard time actually to implement it down all the way in the organization. But from my role, when I go out and I talk with engineers on the engineering level, we are actually very aligned, and everybody wants to go and change. Is really not that many that are the breaking blocks here.
There is one comment here about the factories, actually. I mean, the current factories, could they deal with SDVs at all? I mean, how they...
I have a little feedback from the Tesla point of view. They actually did it the other way around. They made the factory in the production process an essential part of the SDV. So the car contributes to its own build process with the SDV capabilities it has, and they significantly shortened the takt times by doing so. So basically what it means is every component that goes into the car actually starts immediately self-diagnosing its connectivity and everything. But you have to tweak the software for that, not to create like 5,000 errors. So every station, the software is actually changing what it's doing. And by the end of line, your vehicle is actually already, end of line tested. I'm not sure if that was Alfred's question or if he wants to talk more about quantities or something like that.
I think that I took also this direction from that's also my understanding for them, and taking the example you mentioned about Tesla and doing a comparison with different OEMs I have seen. So you didn't have like your preferred tool already in your manufacturing line that you cannot change the way you do software, because if you change, then your manufacturing line is not going to work. What I'm saying is actually happened recently. I have seen that. So already invested a lot in many tools for the manufacturing line. So your tool needs to be compliant with that. So talking specifically about the diagnostic tool chain that we have. So with UDS tools and the way the software is programmed, flash it into the ECUs and the parts in the car, variant management, etc., all configured through the UDS. So that's the way it is. So if you come up with now you flash through normal the way you flash for other non-automotive systems, the FTP or whatever, more suitable technology, then you break the manufacturing line, and then it's not prepared for SDV. So yeah, if you don't change that mindset, then
yeah, it's an interesting thing. Like 10 years ago, Elon stepped in front of us as the workforce, and he said, from today, the factory is a product, and we will make a product that is capable of building product. And like the factory actually had its own software, package and branching and everything, and it was considered to be a product. And his idea behind was then you can multiply it. So you can actually, and that's what I did with Shanghai and actually with Berlin as well, right? You basically duplicate an existing product, and you handle it as a variant, basically. So that being said, very, very strong involvement of the software team, of the vehicle software team with the factory. Downside is we burned out a lot of engineers because I basically have two jobs. But if you do that in a better way, I think it's a revolutionizing way of building product.
And I think it becomes an essential part of SDV concept anyway. So there is an impact, there is a connection. You can always do that step by step, but you have to do something. So just by keeping the things as they are today and making everything else around the SDV domain, you're not going to have your final ultimate benefit of it. So clearly, you have to invest into that part as well.
Yeah, and that brings us basically back to an earlier statement, right? So the whole thing is a bigger picture. You cannot just see, oh, we're building a car. No, you're not building only a car. You're having a factory that builds a car. You have a cloud on top of that. You have a feedback loop. You have a customer who has requests, and you have a service center that needs some help and so on. So all in all, it's not just like, as I said, just mangling metal sheets into the right position and then melt them together.
What do you think about that? I mean, SDV is a change from project to product. I don't know this McPherson definition. I mean, if probably.
I don't know.
You
Robert always knows very fancy stuff. So.
Did automotive, I mean, change from project to product, actually?
Well, I think it's the same transition. Basically, we're trying to build something which is then evolving, not just a million custom things which die the day they are released. So this is possibly the key point which Robert is trying to make here. So short answer, it's in progress. That would be my bet.
Yeah, I would concur on that.
Let me just check.
Yeah, we get our comments are very long today, so I got.
Yeah,
I'll spend some time afterwards to read over as well.
Yeah, there is one comment. This is also interesting because of the business models. I mean, that OEMs cannot really think about having revenue after SOP, so to say. I mean, that continuous revenue, so to say. And this is quite difficult to convince actually people.
Yeah, I think I should hire somebody who worked at Apple and running the App Store because they figured it out pretty well. But I fully understand that this is a transition the automotive industry needs a lot of time for. But there are discussions out there actually to actually offer some sort of environment. Tesla actually did it about a year ago to offer it to third-party app developers and so on. So I think we will see that it will not be as fast as we saw it in the revolution of the smartphone.
Yeah, but one thing that while working with smart TVs, one of the projects I worked at was the first LG Electronics smart TV, so back 2009, and you don't see the same appeal in terms of apps for smart TVs as you have for mobile phones. And not necessarily the apps are going to be the way to make money after market. And I know there are a lot of buzzwords in terms of predictive maintenance and a lot of things. Still, I see few ways that this concretely with predictive maintenance possible to really add value to the customer and then to charge for a subscription lately. But there's Michael Entner Gomez, he's talking about that a lot in LinkedIn and Substack, and he lives close to me, by the way. So this is one very interesting topic, I would say, and I do believe there is no way like crystal transparent that we can say, you are going to make so much money later. So there is a revenue stream clear.
And that exactly gives the headache to the controllers, right? It's like, what do you mean you cannot tell me exactly down to the cent how much money I will make with my product? This is how we always did it.
Yeah. I think, guys, the misconception here is that trying to make subscription working just because we all like subscriptions is not the way to go. We need to follow what is the value for the end user. And if there is the value which they can understand, then after some time, they will be happy to switch. And trying to offer it not as the only mode, but maybe as another new mode based on something which existed forever or for a long time. I think this is the right model how to show, hey, by the way, if you do this, you'll get this extra value, which you may actually want. And then, okay, yes, I like it. I'll go for that. So it needs to be defined and designed for user, not just because we want to generate revenue or anything like that.
100%. And it doesn't always have to be subscription. It can also be a later sale, right? So if I want to add a feature later and I want to pay for it and I get it, then basically cash sale, right?
Exactly.
But that's also hard to understand for the controllers to how you account for that, right? But over time, and here's the good news, over time you will get statistics and you will actually start to understand how you account for that. It's just a transition period now.
Yeah.
100%.
100%.
Cool. We are running out of time. Any final comments from your side? Anything you want to?
We never run out of topics, so that's good.
No, topics. There are a lot of topics. I mean, I think we can talk another hour or so.
Yeah.
But yeah, I mean, if there are no comments from you, so thanks joining, and also
everyone.
to our audience asking so many questions. Yeah, thank you for that, and let's meet next time again. See you.
Awesome.
Bye.
Thank you all. Bye.
Bye.
Thank you guys.